Chapter 7, Homework Problem Number 2. We are given that the average length of time for an individual to complete the tax return form is 10.8 hours. And because the IRS have the entire population's information, that average is the population mean, MIL. And it says the distribution of the length, although it's unknown, but we can calculate, or the IRS can calculate the standard deviation, which is 2, and it is the population standard deviation. So those are the given conditions. And we will look at two problems to distinguish when to use a central limit theorem and when to just use the normal distribution. So for the first problem, we need to find the probability that a randomly selected taxpayer took less than 11 hours. And the key word here is you're talking about one person, okay, one random person. And in that case, we will follow the normal distribution. Now, in here, we are assuming, because the population distribution is not unknown, but I'm just going to assume normal distribution so that I can demonstrate how to use the formula differently, and you get some different result. Okay, so if the distribution is normal and we want to find out an individual take less than 11 hours, then the standard procedure is just to do z equals x minus mu divided by sigma, and our x is the data point, which is 11, and the mu is 10.18 given to us. Sigma is the standard deviation, so it's 2. It's very important to identify the value for each symbol. So then on the top, and you have to do it step by step, okay? You either enter parenthesis 11 subtract 10.18 close parenthesis divided by 2 in your calculator, or you do it step by step, okay? You do 11 subtract 10.18, you get 0.82, and then you divide it by 2, and then you get 0.41 as a z-score. And in that case, you can draw a normal distribution, and you know a z-score of 0.41 is a little bit to the right because it's positive. And if you're talking about less than, we're looking at the probability to the left-hand side. So we need to use a z-table to find a probability that a random data point is less than 11. Okay, and in that case, you look up the z-table corresponding to the row of 0.4 and the column of 0.01. So you will get the number 0.6591. Okay, so if it were to ask you for just one randomly selected person and the distribution is normal, you will use this formula. Now, when to use a central limit theorem is when we are talking about finding the probability of more than one individual. So the probability of 36 taxpayers took an average of 11 hours or less. So key word here are more than one people, and they want to know about the average. Okay, so in that case, you know n is a sample size, which is 36, and because 36 is big, okay, it's large enough, even if we do not know the distribution, okay, of the time that take taxpayer to complete the tax return, we can apply the central limit theorem to inform us about the average. So you will need to apply this formula, okay? Z equal x bar minus mu divided by sigma over square root of n. So this is because of the central limit theorem. And you have to enter everything step by step. So X bar is the average data point. Okay, what number are we interested in? We're interested at 11. You subtract the mu. Okay, what is the mu? The central limit theorem tells us that this mu is the same as the population mean, so it should be 10.18. And the central limit theorem also tells us that you have to divide it by sigma over square root of n. And in that case, you have to identify, okay, sigma is 2. You divide it by square root of n. N is 36. Now, if you were to enter in your calculator, you will do 11 subtract 10.18 close parenthesis. Then you do divide, and then you open parenthesis 2 divided by, find the square root symbol, square root of 36, okay, and then close parenthesis. Now in that, if you can do it by hand, you can verify. It's just 0.82 divided by 2 divided by square root of 36 is just 6. So what is 2 divided by 6? Well, it's 1/3, okay? Or you can write 0.333 and so on. And in either way, you can use a calculator. You don't have to break it down. You can enter the whole thing all together. You get a z-score, and I think it's exact, not approximate. You will get, your calculator should show you 2.46. So now you use this 2.46 z-score, okay? You draw a normal distribution. It should be all the way over here, 2.46, because it's a big number. And it also implies that a big area is to the left of it. So if you say the probability of the population or the mean of 36 individual taxpayers will take less than 11 hours, and you look up the Z table. You look for the row of 2.4, and you look for the column of 0.06. You should get the number 0.9931.